Good morning, everybody. Welcome to our workshop number 16, organized by the ANH. Today, we have the pleasure to give to you the talk titled Geological Habitat, Prospectivity, Socio-Ambiental and Economic Sustainability of Wet Gas LPG in Colombia as Energy Transition Fuel. Okay, just to tell you that in June, we will have those interesting talks. Today, the one that I already mentioned. Next week, we are going to have a very interesting talk given by Ivan Olaya, one of the experts in that area in Colombia. And we're going to talk about the analogies of the trapping systems between the Gulf of Mexico and the Caribbean in Colombia, the Caribbean basin in Colombia. On June 17, in a couple of weeks, we will have the National University with us, talking about the prospectivity of the Cenozoic units in the Upper Mag basin. And the last Friday of the month, as usual, we will have all the findings of the ANH on prospective areas. And we are going to talk about the New Granada seismic acquisition done by the ANH. We will talk about the pilot as well, drilled by the ANH, and also we will talk about the El Miedo opportunity in the Llanos Basin. And don't forget that Friday we will have also the MinCiencias and the Geological Survey with more details about the financial help for students and recent graduated students, professionals, I'm sorry. So don't miss that talk on last Friday of June. This is a map where you have the areas identified by the agency as good to be nominated. So we have 28 in total so far in the year, and we have areas on gas, condensate, light oil, medium oil, and heavy oil. So if you are interested in having a look at any of those, please don't hesitate to address or link that is on the screen and at this time. So you can have the access to any of those opportunities of the talks given during the year, and also the ones given last year. Remember that the agency organized 28 technical workshops last year, and all of them are, all the information of those technical workshops are already loaded in our website. So don't hesitate, use this link and address that information as soon as you can. So we have very great speakers this week. We have Mauricio Bermudez, who is a mathematician, Master Science in Mathematics and in Geophysics, PhD in Earth Science, Professor of the School of Geological Engineering at the UPTC since 2018. Research areas basin analysis, thermochronology, geomorphology, numerical modeling, and tectonics. Welcome, Mauricio. With us, Cesar Mora, well-known geologist with more than 33 years of experience in petroleum exploration projects, expertise in petroleum system modeling, combining basin analysis with petroleum geochemistry and petroleum system modeling. Modeler geologist in companies such as Ecopetrol and Cipetrol, and he has worked as a consultant since 2024. He has been director of Cuenca Asesoría Geológica, SAS, since 2014, professor of petroleum geochemistry and petroleum systems in different Colombian universities. We have also the pleasure to have here Viviana Guarín, geologist from the Universidad EAFIT of Medellín, with a master's science degree in planning and sustainable development from the University College of London, and with environmental engineering studies from the Universidad Pontificia Bolivariana de Medellín, founding partner of, sorry, I don't have the name here, Planation Intelligence. That's the number of the company is core for me, but Viviana will clarify the number of the company that she is the founder. He has more than 25 years of experience in environmental and territorial planning, strategic and environmental assessment, risk management, climate change, early warning, and environmental impacts and reliability in the mining and hydrocarbon sector. She has been advisor and manager regional and rural planning at the en el Departamento Administrativo de Planeación Distrital and consultant at UNDP, the Natural Conservancy del Pico Colombia, and at the Agencia Nacional de Minería, among others. And we have finally Santiago Mora, and our last speaker today, philosopher and master's degree in Latin American political studies from the Universidad Nacional de Colombia, experience in analysis of public policy and government management of hydrocarbon resources. During the last 2 years, he has worked with Cuenca Asesorías Geológicas in the structuring and sustainability projects applied to the hydrocarbon exploration and production industry. And since 2021, he has been working as young research at the Universidad Pedagógica and Tecnológica de Colombia, UPTC, in the evaluation of social and economic sustainability of the LPG business in Colombia. Okay, so thank you very much for the speakers, and welcome everybody to this great talk about the LPG. Go ahead, Mauricio.
Good morning. Thank you very much, Dr. De Armas. Could you please see my presentation, our presentation?
Yes, Mauricio. Go ahead.
Good morning. Good morning, everybody. We are talking today about our project. Is titled Geological Habitat Prospectivity, Social, Environmental, and Economic Sustainability, and Wet Gas LPG in Colombia has an energy transition fuel. This project is an interdisciplinary and collaborative project between private company, Cuenca, a public university, UPTC, y the Sociedad Colombiana de Geología. This is our team. The problem statement: Colombia has incorporated LPG in its energy basket. This is a fossil fuel considered as an energy transition fuel. This represents 2% of the total energy used in the country. This fuel is very important to the residential consumption, especially because more than 3 million households belonging to the social strata 1 and 2 use this for cooking, for normal activities. Currently, the country has lost self-sufficiency in the supply of LPG due to different factors. Among them, we have the absences of gas discovery with high volume of wet gas during last decade, lack of infrastructure oriented to the separation of wet gas in oil fields. We have also instability in decrease of the production in the supply of Ecopetrol. This is the main producer of wet gas in Colombia. We try to resolve 5 research questions. What are the main factors controlling the social, environmental, and economic sustainability of the LPG business in Colombia? What is the geological habitat that controls the wet gas accumulation already discovered in the country? What is the geological and petroleum system model that controls the accumulation of wet gas in the Cusiana and Copiagua area? These last are the largest wet gas production in Colombia. Which are the most prospective area for LPG exploration in the basin with commercial hydrocarbon production? In the last, what is the volume of wet gas prospective resource to be discovered? In order to try to solve this question, we have 7 we have a methodology in 7 basins to apply this. We have the lower Magdalena Valley, the middle Magdalena Valley, the upper Magdalena Valley basins. We have the Cordillera, the Eastern Cordillera foothill. We have the Llanos Orientales Basin, the Caguán Putumayo Basin, and the Catatumbo Basin. We have 11 methods, and today we are talking about 5 of these methods. This is highlight in green color. We are talking today about reservoir evaluation with wet gas, geological habitat and proven place, geochemical interpretation of gases, prospectivity, play fairway maps, in socio, environmental, and economic sustainability. Yes, thanks.
Okay, greetings to giving us the chance to present the results of our research. I'm going to talk about the general framework of the sustainability area. And I like to start with a question. What are we talking about when we talk about sustainability? Or as we say in Colombia, and what is that eaten with? So I would like to start with some historical context. In 1972, it was published an influential study called The Limits to Growth, whose objective was to model economic growth in a finite resource planet. As you can see, the results of this investigation were somewhat controversial because it states that by the end of the century, the civilization will kind of collapse, as you see here in the lower part of the graph. Although the conclusions were controversial, they rose awareness over the capacity of the Earth to support ever-growing human activity. Sorry, one moment, please. Okay, so this study inspired the research for sustainability around the world. And in 1987, a commission called the Brundtland Commission stated a very influential definition of what we now call sustainable development, that is a development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So the question that we now face, because this is an empirical problem that we are facing, is how to measure sustainability. And in this project, we have come with 5 criteria for the sustainability measures that we are going to use to evaluate LPG in Colombia. So the first is the reduction of GHG emissions, of greenhouse gas emissions, the reduction of pollutants in earth and water surface, the reduction of the depletion of natural resources, that is the reduction of deforestation and the use of forest resources, progress to our OSDs, the objectives of sustainable development, that I'm going to talk more in a moment, and the security and the sovereignty of the resource. Okay, so as our topic is LPG, and LPG is an energy fuel, we have researched the state-of-the-art research in sustainability for energy supply. I'm showing right now the scenario that the IEA, the International Energy Agency, has called the STEPS scenario for 2050. As you see, renewables grow steadily towards 2050, and coal reduces its participation, and natural gas and oil come to its peak around 2050. Nevertheless, the problem with this scenario is that it does not meet the goals that have been traced by the international meetings as the COP26, as we know, the general goal that is net zero by 2050 to help reduce the global warming in the world. So IEA has created another scenario called net zero, in which natural gas, oil, and coal reduce its share in the total world energy supply by around 2/3, but nevertheless they still form or take part in the energy matrix of the world energy supply. So the conclusion here is, even with this radical scenario, natural gas, oil, and in some context, coal are going to play a role in the total world energy supply. So keeping this in mind, we have come to ask ourselves, is LPG a sustainable transition fuel? Can it help transition, and in what ways can it help transition? Well, we have found four main ways in which LPG can help sustainable transition. First, as a cooking fuel for low-income households, as replacement for traditional biomass. Second, as a transportation fuel, as replacement for petrol, mainly diesel, because it's less contaminant. Third, as replacement for coal in industrial energy uses, and for heating for rural houses. In this, in this project, we have focused ourselves in the cooking fuel. As you can see, in the last 20 years, the tendency in the world has been to replace biomass with gas. This is humid, wet, and dry gas. And electrification, which is the other alternative, as you see, is still very, very low in the total world supply of cooking fuel. This being said, some countries have, in the international scenario, have put up with some public policy that has boosted the use of LPG as cooking fuel. I'm going to give just two examples. India, that is #3 consumer of LPG worldwide, and Brazil, which is #9 consumer worldwide. These two, in the case of Brazil, it is expected that 25% of the residential energy will be LPG energy. So this is just to give a dimension of the alternative that LPG has become for residential energy in the world. So now we ask ourselves, in Colombia, is LPG in line with the general framework and the general plans that Colombia has traced for the energy transition and for becoming a modern energy country? So we find three criteria where LPG can help. First is emission reduction. In the scenarios that Colombia has compromised with 20 to 30% of reduction of greenhouse emissions. Second, the energy access, that is the OSD #7, that states that people should have access to secure and cleaner energy sources, and the energy efficiency that can help, that would come with the replacement of the biomass by LPG, which is a lot more efficient than the traditional biomass for cooking fuel. Okay, so we also have asked ourselves, what is the regulation that LPG has in Colombia? And in this, we have based ourselves in first in the political constitution, the laws, decrees, and external circulars that involve LPG, and the national plans that Colombia has put out as its as the general goals. And we have some regulation highlights. First of all, is that LPG is a public domiciliary service regulated by Ley 142 de 1994. This is very important because this law states that the state has the obligation to promote payment schemes for low-income households. And in last instance, it must intervene directly in the market to guarantee the provision of the service. This is very important because it means that LPG is an strategic fuel for the government and for the state of Colombia. And indeed, there are some progress towards this. There are some subsidies that are being created, and the regulation of LPG is becoming stronger by the day. Second of all, there is a price regulation because of the dominant position of Ecopetrol. This is important because Ecopetrol, because of geological reasons that are going to be cleared out later, has the dominant position of the supply of the fuel in Colombia. Second, the distribution, transport, and commercialization of LPG is subject to regulated competition. And lastly, since 2017, there is regulation for auto LPG, GLP and Naughty GLP, that is in Spanish, and that is LPG can be used as fuel for cars and boats in the country. Okay, so I would like to finish this with some insights on the supply and demand of the LPG. First of all, as I said before, Ecopetrol has a dominant position in the market. As you see here, it supplies around 90% of the demand in the last 5 years. And another interesting thing is that the demand projections states that we are going to grow around 3% in the demand side until 2030. This demand is going to be driven by the residential sector and also by the industrial sector that also consumes an important part of the LPG. Some final considerations for the sustainability of LPG in Colombia are that 6.5 million people use LPG as their main fuel for cooking in Colombia. So the security of the supply is crucial. Second, the demand is expected to grow, and with the incentives from the reduction of greenhouse emissions, it is possible that the growth will be even bigger than the expected. Third, the programs for replacing biomass for secure and cleaner fuels for cooking will also raise the demand for LPG in the country. And finally, I have a question. We have a question, sorry, to ask is how are we going to guarantee supply? Is it going to be through imports? Is it going to be through our national production, developing some new research fields? Are we going to increase the efficiency of the plants? That is the question that we are asking right now in this part of the project. Thank you.
So, good morning. Are you looking at my presentation? Yeah. Now? Can you see my presentation?
Sí, ahí está.
Okay, thank you. So Today I'm gonna talk to you about the socio-environmental sensitivity analysis that we are doing also for this project, and it is related to the transition or from using firewood to LGP. So first of all, I would like to remember, as Santiago just told you, that in the country we still have 1,600,000 households, most of them rurals, that are still using firewood for cooking. In the maps, we can see the areas where most of these households are located. In the map of the upper side, we see that, for example, these families are concentrated in Córdoba and Cauca, Nariño and Antioquia. But when we see the percentage of the rural household that still cook with firewood, we see that the map changes a little bit. For example, in Baupés and Bichada, we have still nearly 90% of the rural household that still cook with firewood, which is something that the country and the government should take into account very urgent, because of all of the environmental impacts that this activity produce. Here we can see the main socio-environmental impacts that are produced for firewood burning and cutting. In the first place, we have the loss of vegetation cover, the time demand that implies for the families going to cut the firewood and then to cook with it. In the third place, we have all the air pollution that is related to the firewood burning. And here, one of the most important is the generation of PM 2.5, and also the generation of greenhouse gases, as Santi said. And all of that have an impact of the quality of life, in the quality of life of all of those people, all of those households that still cook with firewood. So some figures about that is that, for example, in 2018, these 1,600,000 families that cook with firewood spend 6,001,000 tons of firewood per year in that year, which of course implies loss of vegetation cover and pressure on our ecosystems. And also there is something very important to see when we know that the cooking with firewood implies an increased demand for time for unpaid work. This especially is important for women and children, which are the usually who are in charge of doing the cooking at home. In the chart, we can see that women in average work between 7 and 8 hours a day in unpaid work. So doing this cooking with the firewood could increase that time that it used for unpaid work, and reduce the time that women and children have for doing other activities, paid work activities, or relaxing or studying. In terms of health, the WHO has stated that 3.8 million people die every day as a result of household exposure to smoke. And also, this smoke increases the risk for heart disease, stroke, chronic obstructive pulmonary disease, cancer, and pneumonia. And in Colombia, the Ministry of Environment stated that 1,000 people died from intramural contamination due to cooking food with firewood. and 50% of the pneumonia deaths in children under 5 years are related to household air pollution. So as we can see, this is an issue that demands attention of the government. And LPG is an excellent alternative for being cleaner because it doesn't produce smoke or PM 2.5. Is faster and more efficient, produces less greenhouse emissions than nearly all of the fuels of our energetic basket, and does not degrade the forest. So because of that, we think that LPG is a very good option to replace the firewood for cooking and other biomass fuels. So the environmental sensitivity analysis objective is basically to analyze the sensitivity of the areas of possible impact in a proposal to replace firewood with LPG. And this is made to specifically to prioritize territorially where to start and where to do this replacement. So the methodology consists in identifying the territorial factors related to the main impacts that are caused for using firewood for cooking. So we, at the moment, have 3 territorial factors, which are the acute respiratory infection consultations, the presence of sensitive ecosystem, and the multidimensional poverty index that is produced by DANI in Colombia. So when having these indicators, then we represent them in a map in terms of different levels of sensibility. So the first map that we can see is the map of the presence of sensitive ecosystem that is ranged in different levels of sensitivity. You can see in the map the red areas and the orange areas that correspond to the high sensitivity, very high and high sensitivity. And you can read what you can read in the map is that in these areas is less desirable that a household take wood from these ecosystems to cook the daily food. The second map is the map that is where we graph the multidimensional poverty index. You can see in the red areas the most poor areas in Colombia. So what we understand in the interpretation of the map is that in these areas it's less desirable that people cook with firewood, because doing that it could increase the level of poverty of the families. As we can see in the map, these areas are located in the borders, most of them the borders of Colombia. In the third map, we can see we graph the acute respiratory infection consultations. And as we can see, the highest number of consultations, these are figures of 2021, were in Guajira and Bolívar. And the lecture of the map is that it's less desirable that in Guajira and Bolívar families use firewood because it could make worse their health. With these 3 indicators, we built finally an integrated sensitivity indicator. And this is graphed on in this map. This is the result of combining the 3 indicators that already showed. And what we can see is that, as we saw in the other maps, that areas in red and areas in orange are the areas that has the more sensitive, the highest sensibility for the people to cook with firewood. It means that we should try to start replacing the firewood for LGP, and in these areas that are in red and in orange. Of course, we have to cross some other variables to conclude where is easier also to start the replacement. And so we are still working on it. Thank you.
Okay, good morning. Good morning, everyone. Yeah, I'm going to present some results that we have now, but it's important to remember that this represent just 40% maybe of the total timing we have for the project. Then this is a brief summary of the results we had for this first step in the research approach. First point that we want to talk is to remember everyone where are located the LPG in terms of the hydrocarbon generation processes. And here we have a typical distribution for gas and liquid hydrocarbons. We can see that here between methane and butane, we have the gases, the typical gases. Then we have this frontier here for the pentane. And then we have liquid hydrocarbons. By definition, we call LPG a mixture of mainly propane and butane. And according to the general picture for the generation processes, that LPG, that kind of gases are located here at the end of the oil window. That's the only place where we can have that kind of gases. It's not possible to have too much at the beginning because the low maturity level, and it's impossible to have LPG at this level because the secondary cracking processes. Then that means that it's a very, very good, the presence of LPG, of the presence of propane and butane is very good to match the basin modeling for a basin, thinking in that we need a soft rock interval with that kind of maturity level. First topic we are going to talk is the gas geochemistry for the Colombian gases. We have a database. It's not too much information, really. We don't have too much, but most of this information got from the ANH for a project that was developed last year. Here we had information for 193 samples. This is the location map for that samples. And we have here information, the statistical analysis for that data in terms of methane, LPG, and ethane. You can see that we have a lot of samples with more than 5% of LPG. The relationship between methane and LPG shows a very high correlation between these two. That means that the processes is probably all these contributions, all these different gases are related with the same geological processes. Also, we can see that in general, looking all the 7 basins, we have a range for LPG that goes from 1% to 92. 92 is a very, very high value. And the P mean will be is around 2%. this is a very important point for the analysis. From the analysis, 65% of the analyzed wells have more than 5% LPG. Why 5? Why are we using 5? Because we know we have a very strong evidence that LPG contents higher than 4% can already be, I'm not sure about this word, profitable. We know we have the projects, and even from the last century, we had projects with this kind of composition, with kind of a level of wet gases, and we know that it's possible to do business with this kind of concentration. And another important point is that the P15, as you can see here in this graph, here we have LPG and the probability to have LPG according with these results. We can see that the P15 is close to 7%, which is really high. It's 7%, but you can see how many samples we have with a very high probability. The main, the highest content of LPG is located in these fields in the Llanos Basin, API, Redondo, Caño Limón, Corcel. They are really high. In terms of the geological processes, geological and geochemical processes to get these gases, the information we have that is related with the general concentration of the gases C1 to C5 and the isotopic composition of every one of these compounds, we can say that more of the gases are thermogenic. More than 90% are thermogenic gases according to this classical interpretation. And also we have mixtures with gases that has very low isotopic composition. And also according with this classical, we have some biogenic, but anyway, right now we have a strong evidence that we were calling biogenic something that could be thermogenic. Some of the dry gases, especially, for example, in Lower Magdalena Basin, are dry, but we have evidence that includes the presence of liquid hydrocarbons in the same trap that suggests that we have just gas from secondary cracking for a very high maturity level. That kind of gases are located here in this kind of correlation, but you can see that most of the gases in Colombia are coming from primary cracking. That means are related with the oil into the oil window, the late generation stage, which is very important when we will be talking about prospectivity. Okay, this is the general picture where we have time just to show some basins, and then we are going to start with the foothills area, with the Cordillera and foothills. Why here? Because it's the most important area. The foothills is the most important area where we have LPG production. It's the most important area for the supply of these gases for the country. One of the things we are doing, and one of the things you are going to have in the project, we don't have too much time to see this, is we are doing a match between the presence of gas, of Colombian gas, and the specific wet gas. We are doing a match of this with the geological framework, with the tectonic, with the stratigraphy, and also with the petroleum systems. We are going to try to explain for every basin how this is matching, why we have that in the specific areas in the basin that we are studying. Yeah. And here we have the a summary of the results we have right now for the foothills, Cordillera and foothills. LPG range is going from 1 to 41%, which is very good. PMIN for LPG is 11%, very high. Remember the boundary, the frontier around 5%. Also, a very important point here is that 82% of the analyzed wells have more than 5% LPG. And the probability, the P15 for LPG is 8.5. According to the geochemical information, geochemical characterization, those gases are thermogenic and are related with primary cracking, late generation. This has a very important implication for the petroleum systems of the basin, because we need to calibrate the petroleum system model with this kind of data. And here we can understand why we have the main production area here. That's the reason too that we are doing a special research in the Nuchia syncline, in the influence area of the Cupiagua, Cusiana, Pauto, Volcanera fields. We are trying to understand why we have LPG there on that kind of proportion, and especially where we can go in order to try to find similar conditions, similar geological and geochemistry conditions for the future discoveries. And now we have the information for Llanos Basin. Here we are not including the foothills. And for us, for me especially, I was studying gases, the original database that has more than 20 that had more than 20 years ago. We were studying that data, but for me this was a surprise. In Llanos Basin, you can see here the composition of the gas. The blue color correspond with methane, and the other colors correspond to wet gases. So there we have propane and butane. And you can see that we have a lot of wet here in this kind of samples. The LPG range is going from 1 to 92. The P-mean is 20. 20 is very high. 20% is the P-mean. 85% of the analyzed wells have more than 5% of LPG. And the LPG probability for P15 is 11.8. That means the Llanos Basin is a very special basin, because we have, for example, we have there oil, we have heavy oils, but the gases, most of the gases are really wet. It is approved that the mixture of the different hydrocarbons pools of charge, we know that using another kind of information, but this is approved. This is another way to see this kind of complex model for the petroleum systems in the basin. Also, we know that most of these or all of these samples are thermogenic and are related with primary cracking. We have the same exercise for the other basins, for Lower Mac, Middle, Upper Mac, Catatumbo, and Putumayo, but we don't have time to show everyone. Now we are going to talk about reservoirs, about production, about the general picture coming from the reservoirs. This is a map of the excuse me, just a moment. This is a map with the current scenario of gas in Colombia. Here we can see production, the highest production, annual production correspond to the red points. And you can see we have that kind of points, of course, in Chuchupa and Ballena. And also we have these areas in the lower MAC. This is the most important area for gas production during last years in Colombia. We have an additional important production in the middle MAC in Catatumbo, the main area, which is located here in the foothills. And we can see that in most of the llanos, the production is low. And it's the same situation we have in the southern part of the middle MAC, in the upper MAC, and in Catatumbo areas. Here we are trying to compare the certified gas for all the country, certified by the ANH, with the certified gas excluding foothills. And we are using data for 2021, for the last year. And here we can see that the production was 667 GCF total production for last year. And for the basin, excluding foothills, we had 196, 30% of the production, more than 30%, was related with the foothills. Also here we can see that the gas transformado is the name that ANH used, that is including LPG, is 25 GCF, or was 25 GCS last year. And without foothills, this was 5.6. And also, another important point, thinking in the topics that Santiago and Viviana were talking, is that we have burned gas. We are burning gas. We have 11 in all the country, and we have almost 10 excluding foothills. That means in the foothills area, we are not burning gas. That's important. That's good for the country. But anyway, this is one of the points that the country needs to change. Okay, this is a summary. This is a summary, a preliminary summary of what we are going, what we have with this information. The first map shows the associated gas. 250 fields produce gas associated with the oil production. You can see here that all these, more than 70% of the gas fields in Colombia are associated gas. This is very important for different reasons, but especially because with this, and because we are trying to understand the processes to have LPG, the geological and geochemical process, we know that the only way to improve the resource of LPG for the future, the new discoveries, will be tied with the new discovery of oil. In other words, we need oil fields if we want LPG. Most of the LPG are related with that, are related with the late generation processes. The only way to have more LPG, new reserves, will be related with the discovery of oil, because the nature of these processes, the nature of the LPG is related with the petroleum system. The other point is that a lot of these, from these 250 fields, 215, 86% of these fields are defined as producer of wet gas. That means they have more than 5% of C3 plus or wet gas. This is very important. This is very important because now we know that we have the opportunity to get more LPG. We already discovered that LPG. And we are using some part, but there is an option to use this without new discoveries. We know that it's LPG that we can use, the country can use in order to support the demand, to support the cooking, to support the people. That's 6.5 million people that are using LPG. And this, the final map, is also very important because here with black and orange, dark orange colors, you can see the fields where we are burning gas. And you can see that it is happening in Middle Mac, it is happening in Llanos, Upper Magdalena, and in Putumayo Basin. The average for Colombia is not too high, but it's important, 11 GCF. But you can see here that it is changing from one basin to another. And that means we need to improve that. We need to stop these processes of burning gas. The country needs that because environmental and problems, but also because we have the opportunity to use that LPG. It is almost a crime to burn LPG because we need it. The country needed it. People needed that LPG. And we have to stop that. We know that change is going on. We know that the country is going to stop 100% that. But here we can see that it is a problem and it is an opportunity. It is an opportunity for business. It is important too for the country. Okay, I think we don't have too much time. This is the kind of maps we are going to have. These maps that are summarizing the entire country, all the basin we are studying. You will have in the project the same kind of the same set of maps for every one of these basins. And I want to show just this about Putumayo Basin. Is all 100% of the gas is associated, 100% of the gas is wet, and we are burning 54% of that gas. We have to stop this, and this is a business opportunity. This will be good for everyone to stop burning gas in a basin like this, like Putumayo Basin. Finally, we have some preliminary conclusion. The gas associated with the production of with crude oil in Colombia shows that 80% of the cases correspond to wet or rich gas that could be used to transform it and obtain natural gas and LPG. Most of these gas correspond to primary cracking, typical primary cracking of the late oil window. All the basins with hydrocarbon commercial production has option for LPG. Llanos Orientales, Upper Magdalena Basin, and Putumayo are the basins with the highest content of LPG. The fields from the foothills, Cusiana, Cupiagua, and the others, are the most important accumulation of LPG in the country. The production and transformation of that gas production into LPG will depend on a large percentage of the internal supply. Other point is that the accumulation of gas discovered in the lower in the lower Magdalena Basin during last 10 or 15 years are mainly dry gas. It has a tendency of dry gas, but they are very important for the supply of natural gas. we think, we believe, according to the data we have and the interpretation we are doing, that most of this natural gas, dry gas, is also thermogenic. It is not biogenic. And the main evidence for that is that in many fields with dry gas, we have liquids, we have condensate. And finally, given the need to finish burning gas, the transformation of associated with gas to generate products such as LPG must be implemented, especially in areas that today consume LPG and or have high consumption of firewood. Okay, that's all we have that in this preliminary approach. And finally, I would like to say thank you to the ANH. Gracias al MinCiencias, a la universidad, y obviously thanks to the group, to the research group that is working a lot in this project. The methodology we are using here is not is really new. We are trying to develop the methodology. Probably this is the first time some group is working on that with the LPG, and it's not easy to get information in general, information for other countries. That means for us will be very important your contribution. We know that there are people that are working on that probably from the different point of view. And if you have comments and suggestions, that will be very welcome for that. Thanks a lot.
Thank you, Cesar, for this presentation. From the ANH, we'd like to thank Santiago, Mauricio, Viviana, and of course, Cesar, for this amazing presentation. That is a topic that everyone should be interested in because it's mainly the energy for the near future. So we got a couple of questions. I would like to clarify that we'll be shortly speaking with the people of communication from the ANH, because as Germán Bayona pointed out, the presentations haven't been uploaded since the 8th of April. So we'll be talking with them for upload the presentations that have been given in the past weeks, because that's quite important to have them up to date into the ANH webpage. So, Cesar, meanwhile, there is a question by Ivan Olaya. Those 11.9 GCF that you presented, in how much time, or how long do you reckon those are for?
Ivan, that were the production for last year. That's the official data from the ANH. That was the burning gas during 2021.
Okay, thank you, Cesar, very much. There is another question. Why do you contemplate the offshore basin, the Caribbean offshore basins, and the Caribbean fault belt for the potential of gas? But why is not contemplated so far? That's the question.
Okay, that it is a good question, but from the beginning, the project, our idea was to work with data. We needed to use data. We needed to characterize the gas, and then the first step for this kind of approach will be to study the basins with hydrocarbon commercial production. That's the reason. In the Caribbean, obviously, we think there is an option for wet gas. We are sure that there is an option, but now we are studying the commercial production in the basins with commercial production in order to understand how this LPG that we already have is how are the processes related with this. That's the reason.
Okay, thank you, Cesar. Let's see if we got any more questions. Okay, so we'd like to thank all of the attendees, of course, the speakers of
Thank
today.
you very much.
And to remind all of you that next week we'll have our number 16 workshop that is recent discoveries in the Colombia, Caribbean, and Gulf of Mexico, the analogies and prospectivity. This is going to be quite interesting because all of us know how important is the Gulf of Mexico in terms of production and how development, and how maybe we can apply of maybe which analogies we have. So again, thank you and see you next week. Do not forget that we have all of the presentation, as I mentioned before, all of them will be uploaded shortly with the recent ones into the ANH webpage. Thank you very much.